Hello passenger, this is Captain Marco speaking. I would like to welcome you all to the Discovery Day flight. We will explore how airplanes fly using engaging content and engineering simulations. Let's start with a question. Do you know what STEM stands for? STEM is a curriculum to educate students in science, technology, engineering, and mathematics. STEM education is important since it's directly used in many modern applications. For example, electric cars require slick and smooth shapes to improve their aerodynamics and reduce the energy consumption while moving. Also, the battery performance is a key point to increase the car's range and safety. Car manufacturers are also implementing self-driving technology. Sensors let the car identify obstacles, vehicles, and pedestrians so that it can drive itself safely. Some cars even park themselves without your help, so you can sit and let them do all the work. Another cool application of STEM knowledge are robots. There are numerous places where robots are used. The list is pretty long. They're used in competitions, emergency situations, and they can even help us clean our homes. One of the most common forms of robots is the so-called robotic arm. These arms resemble the human arm, and they are mostly used in industry to execute repetitive tasks. They can move a piece from one point to another, drill holes, or mount different components together much more efficiently than humans. Indeed, robots can do the same movement over and over with extraordinary precision, and they can be extremely gentle in handling very small and fragile components, like, for example, a computer chip. Robotic hands are also pretty interesting objects that are leading to the path to have bionic prosthetics, so that users will easily use them to simplify their everyday life. STEM knowledge applies also to any form of power plant for electricity generation. Other than gas and coal, we can see energy produced by hydroelectric sources, nuclear power plants, and wind farms. All of these require an immense knowledge of science to have high efficiency and be structurally safe. All the subjects included in a STEM curriculum are fundamental to technological development. Think about how much time it required to move from old fridges to modern ones that have ice makers and they are connected to internet so that you can even know the status of your food, or if you are running out of it. STEM is required to achieve this kind of progress. The same applies with cars. We move from this to this thanks to the advanced knowledge of physics and material properties. I know what you may be thinking. Science, math, this must be so boring. You probably only like STEM if you're a super nerd surrounded by books. Well, that's not true. STEM can be cool. Experiments make learning STEM cool. Simple chemistry can magically change the color of a substance, or you can have impressive reactions such as this one, where the strong expansion generated by the reaction creates this foam structure out of thin air. Remember that you always must be cautious, well-trained, and in a safe environment in order to perform these experiments safely. Big companies often need to perform field experiments before delivering the final product. For example, wind turbines that generate electricity using wind are very large structures. The process to build them is complex, and the transportation of these different parts can be a challenge. That's why it is important to test a full-size model to verify that it will perform as expected. But how can you perform such a test? You will need a lot of money and a lot of space. Or you can do it at your home using your laptop. STEM is even cooler with ANSYS engineering simulations. Real-life physics can be simulated in a virtual space using our computers. For example, we can represent a cyclist and a bike with a virtual 3D model. This model can be used to see how the air moves around the cyclist and understand how their posture can make them go faster. We can even analyze how the bike frame will perform structurally out in the real world. We can do all of this without the need to build a bike or perform experiments. You can even test cars, airplanes, or buildings that will not fit inside your room. We can study a vehicle's suspension and analyze the forces acting on the structure so that we can predict possible failures. Engineering simulations also let us analyze the temperatures in electronic devices. We can quickly move parts and modify the design to improve the airflow and cooling performance. This is the power of engineering simulations.